Hello everyone, welcome to chapter 14 of the Java tutorial, which is about loops. Loops are really essential if you develop algorithms, which is of course much of our research and development work here at the University of Bonn. Okay, so let us look at a simple example first of all. It's again a class. We call it myCounter, and it contains nothing else than our public static void main method. So, and within this main method, we are declaring and initializing a variable I of type int, and we assign to this variable the value 0. Now, next, these 4 lines of code, that is actually our very first loop. It's actually a while loop. You will see that there are also other types of loops in Java. And the while loop has always this structure. You're saying while, then in round brackets there is a certain condition. This is an expression that is evaluated to true or false. And as long as this expression evaluates to true, the code within these curly brackets is executed repeatedly. Yes, so we go here to this while loop. Okay, I has value 0. For sure that's less than 10. Therefore, these 2 lines will be executed. And accordingly, what is happening? The value in variable I will be printed to the console, and afterwards this is the increment operator. Variable I will be incremented, so the new value is now 1. So that was now the first iteration of this while loop. And then again we continue checking this condition. So now I is equal 1, and yeah, for sure that's still less than 10. Therefore, a second iteration is performed. I is reported, value 1, and I is incremented from 1 to 2. And after that, again, we evaluate whether or not we should continue with the next iteration. And of course, because in every iteration here we increment I, then in some iteration this will evaluate to false. And that is precisely when the while loop is over and we continue with any code that is here after this closing curly bracket. In this case, there's no code following up on this, so meaning the main method will be then terminated. That's how this while loop works. In our example, well, what would be the output? First number that will be printed to the console is 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is still less than 10, therefore it will be printed to the console. Then I will be incremented to 10. Now this condition does not hold anymore because 10 is not less than 10, and therefore the while loop is completed, and 10 will not be printed to the console. So what we have then is this output, numbers 0, 1 up to 9. So that is fairly straightforward. I think this while loop exists in almost every procedural programming language, and if you have implemented any other program in some other language, you are quite familiar with this. There is, however, the for loop. This is also, if you compare different programming languages, it's quite different. So the for loop in MATLAB, for example, is very different from the for loop in Java. Okay, but basically with the for loop we can do quite similar things. Often it's more compact to write the code using the for loop. So that is the form of the for loop. So you have for, and then in these round brackets you have actually some more complex expression, but within these curly brackets here That's again the code that should be executed in every iteration. So the main difference is just here, this within the round brackets. In the while loop, there's only this condition that is evaluated before every iteration. And in the for loop, we have, you see actually 3 expressions which are separated by semicolon. So the first expression here, that's just some initialization. So this has basically the same effect as defining here this int I in the for loop, in the while loop example, sorry. Yeah, so this is just the initialization of this variable I. So you can put it in the round brackets of the for loop, thereby you save, so to say, one line of code. The second expression after the first semicolon, that is the condition that is evaluated before every execution of the loop, just as in the case with the while loop. So before we execute the code between the curly brackets, we check whether this condition still holds. And now the third expression here in the for loop, that is precisely, well, one expression or one command that is executed after every iteration, at the end of every iteration. So for example, we can use this to put the increment of our variable I. And then we have a nice compact way to code basically the same example that we have here coded with the while loop. So here we say for some integer variable I starting with value 0, then while this condition holds, and then after every iteration increment I by 1. And accordingly, with this example, executing the main method will again output these numbers 0 up to 9. In general, however, you can place here within these round brackets arbitrary expressions. Yeah, so there's no need to initialize an int variable here. You could put also, I don't know, the initialization of a Boolean variable there for whatever reason that would be useful. But this, I would say, is most common, that you have maybe a loop iteration counter. Yeah, so this is a counter which is counting up the number of iterations. Here you have basically a condition that needs to hold true before you decide to continue with the next iteration. And here you have often this increment to increase this loop iteration counter by 1 after every iteration. However, in principle, here you could place any code that should be executed before the first iteration. Here you should place any logical expression which needs to be evaluated before every iteration. And in particular, of course, the iteration will be performed only if this logical expression holds true. And finally, here after the second semicolon, you can place any expression which will be evaluated or executed after every iteration, meaning after every execution of this block that is delineated with these curly brackets. So that is the general form of this for loop. Well, I would also like to point out that there is a very nice other form of the for loop, but before I get to that, let us use the for loop that I have just introduced to iterate through all the values within an array. Okay, let's get to this example here. We have here a variable a, which is an array of type int, and we initialize this array with 4 numbers. First element is 1, second 5, third is 2, and last and fourth element is 3. And now what we would like to do, we would like to print all the values within that array. And what we do is simply, well, we use this for loop. We use such a variable I to count the number of iterations. So before the first iteration, we initialize this variable with value 0. Then after every iteration, we will increment this variable by 1. And basically, we will perform such an iteration only if this iteration counter here is still less than the length of our array A. So in our case, the length of A is 4. So only if I is equal 0, 1, 2, or 3, this iteration here will be performed. So we will then read out the value at position I of our array A. This number will then be assigned here into this local variable z, and this will be then reported, printed to the console. So what we will get then, if we run this program, it's 1, 5, 2, 3, so we will get exactly these 4 numbers within the array. And actually this condition here is very important, so that we terminate this loop as soon as we have reached the last number, the last position of our array. So otherwise, if we would continue incrementing I and trying to access now maybe the element at position 4, yeah, so the 5th position in array A, then we would get an array index out of bounds exception because we try to access a position of our array that does not exist. But with this, well, with this condition here, we make sure that we access only those indices that are valid indices for array A. So now let's get to the second form of the for loop, which I would like to introduce on this slide. It is in particular useful for iterating over all the elements within an array. So what we are doing here, basically, we have an array A of type int. We instantiate this array with these 4 numbers in these curly brackets, 1, 5, 2, 3. And now you see this for loop, it has a completely different form. It does not contain any semicolon. So basically, how to read this for loop is that you're saying for each int z within the array A. So you're iterating over all the elements within array A. And in each iteration, the current element is referred to by z. And if we then simply print this value z to the console, we will have the same output as before, namely 1, 5, 2, 3. This is, I would say, the short version of the for loop, which is useful in particular for iterating over the elements within an array. The same form is actually used to iterate over the elements of some other container objects, which you do not know yet, which are, however, quite important also for advanced programming, like list objects, for example. Yeah, lists are data structures also allowing you to keep an arbitrary number of values, and with the same form, this for each loop, you can iterate over all the elements within a list. Here we are using this for each loop to iterate over all the elements within an array A. And with this short version of the for loop, there's no need anymore to introduce this index I. So we are just directly accessing all the elements in A in order from left to right. So we can do the same with arrays that store point objects, for example. So here we have a new array A of type point. We instantiate this array to be large enough for 3 points. Yeah, remember that basically when we instantiate, when we create an array, we need to decide about its size. There's no way to change the size. There's no way to change the size of the array later on. So this needs to be well thought through, I should say. So here we have an array of size 3 then. And this array we can fill then with 3 point objects, each of which we generate with a constructor call. And then afterwards I'm using again this short version of the for loop, or let's say the for each loop, which you can nicely read: for each point P in array A, do the following. And the following is then contained within the curly brackets. Here it's just one line of code, namely again a call of our println method for printing this x-coordinate of the point P to the console. Well, that was all concerning the while loop, the for loop, and the for each loop, meaning the short version of the for loop. In the next chapter, I will show an example how to work with files. Thank you very much.